This is the Bagasse boiler, created by Pierre and Colin, also known as the Bagasse Bros. Did you know that sugarcane can be turned into a brick? Well, we'll show you how this is possible by the end of our presentation.
Sugarcane has been a prominent cash crop for many centuries, and sugar mills take sugarcane and efficiently process them into sugar and molasses, which are then sold. There is one flaw with milling, though: what to do with its byproduct. Bagasse is a dry, pulpy, fibrous material created during the milling process. Made primarily of sugarcane stalks and leaves, and in 2018, 4.6 billion tons of bagasse were produced worldwide, costing over $500 million to store. So then, what can be done with this abundant byproduct that is just rotting away? But why does this problem concern us in the first place? Well, I am from a multi-generational sugarcane farming family in southern Louisiana. As a kid, I witnessed the massive problem of bagasse. Sugar mills in the local area had to pay for the unwanted byproduct to be burned, or they would just collect the bagasse into piles to rot.
This is where the Bagasse boiler comes into play. After about 2 months of designing, modeling, and manufacturing, we were able to create a fully functioning prototype. We did go through quite a bit of trial and error, but that only allowed us to produce a better final product in the end. With all of this in mind, let's take a look at our prototype so that we can explain how it corresponds with our global goal of responsible consumption and production. So this is it. The Bagasse boiler is our custom project that can successfully burn bagasse to create two separate products, which are energy in the form of steam and another byproduct called fly ash. Steam can obviously be used to create energy, but fly ash, on the other hand, has a different use. Its main function is to act as a strengthening agent in bricks and concrete that is cheaper and more sustainable than its peers. In short, the Bagasse boiler is able to create two separate products by only using one process, and both of these end products are highly usable. With that being said, let's delve into how this all works. For our list of needed materials, we have a bag of bagasse, an aluminum cover plate, a separate wooden cover plate, a solid barrel for the smokestack, and then another barrel that has two welded end caps, a lever to release the steam, and a pressure gauge. Then we have the actual boiler itself. We have pre-drilled holes to let the fire breathe, rods to hold the suspended grate, and then two more holes that hold the pressure vessel. This is all of the materials put together. As we add the initial 3 pounds of bagasse, the fire will continue to heat the water inside of the vessel, which will eventually begin to produce pressurized steam and fly ash. After about 30 minutes, we began to build about 15 psi of steam. Once we had the fire burning at a good pace, we added in the other 3 pounds of bagasse. Another 30 minutes later, we were producing well over 50 pounds of pressure at an exponential rate. It does take a while for the process to get going, but once it does, it's possible to create very high levels of pressurized steam. After we completed our test, we found that after burning 6 pounds of bagasse, we were able to produce just over 1 pound of fly ash and well over 50 psi of pressure. Considering this will be done on a much larger scale in practice, the amounts of these products that will be produced will be much larger.
Our invention is greatly needed in Brazil, India, and China, who just so happen to be the 3 largest sugarcane producing countries, which are also all developing economies that could use the energy produced by the bagasse boiler to power businesses, communities, and governmental facilities. Our invention will massively affect the sugarcane industry, as it allows the sugar mills to turn a waste product into a massively profitable energy and fly ash source.
This has been the Bagasse boiler, the responsible way to produce bricks and energy from sugarcane waste.